Our next session is the technical session, the reliability edge in PCB assembly, synergizing materials, equipment, and process for zero defects. I request everybody to stay back because we have an interesting technical session that's going to be happening now. Our moderator for the session is Mr. Richard Putota, the Senior Vice President, LCNA, and Senior Director, McDermott Alpha, to please join us on the stage. Can we give a huge round of applause, everybody, together? Mr. Richard Putota is a distinguished leader in the electronic manufacturing industry with over 37 years of expertise spanning PC fab, semiconductor materials, and electronics assembly. Currently serving as the Senior Director of Business Development at McDermott Alpha, Mr. Putota has been instrumental in advancing electronic materials and processes, having trained over 10,000 engineers across India and overseas. On the panelists, we have Mr. Saktivel, General Manager, MST Manufacturing Technologies Private Limited, to please join us on the stage. With over 30 years of professional experience, Mr. Saktivel specializes in providing advanced front-end solutions in PCB CAD, CAM, manufacturing and assembly. His expertise includes PCB manufacturing and EMS DFM aimed at improving production yield and overall process efficiency. We welcome you for the panel discussion. And we also have on the panelists Mr. Parameswaran S., Head Product Transfer and Digital Manufacturing, Nokia Solutions and Networks India Private Limited, spanning over 30 years in the electronic manufacturing industry, currently leading the product transfer and digital manufacturing function at Nokia's Chennai factory. May I now request Mr. Jagadish Rajagopalan, ESDM, Plant Head Larsen and Tobro, to please join us on the stage. His expertise spans electronics manufacturing services and smart factories, covering SMT, system integration, high reliability manufacturing, industry adoption, and world-class quality systems across consumer electronics, automotive, industrial, data center infrastructure. Over to the moderator, and can we give a huge round of applause, everybody together, before the panel discussion starts?
Hello, good morning, everyone.
May I request the one standing there, take the seats, take the front seats, okay. Yes.
Good morning, everyone. As we heard from the previous session, right, one thing Elon talked about in about 6 to 7 years, what would we give from India to the world? The world will depend on India, right? And for that, one of the core subject which we are going to discuss in this session is the reliability edge we have in the assembly process on the products we make. And for that, we have a very eminent panel here, especially if I look at this panel, which has got, each one of them are in the industry over 30 years. So combinedly, if you include me, we are about 120 years of experience to deliver this session in 60 minutes. So you would definitely enjoy this session. We are going to deep dive into things which we do well in our processes in the factories, and the outcome. We are seeing that how we enabled the reliability of the products we do, and how they were enabled through our process-centric approach. So I am very proud to introduce the first panelist, because we will hear more from them. Saktivel, General Manager, MST Technologies Private Limited. I would definitely say is one of the unsung heroes of our industry. People who have met him personally, they will talk about it. Those who don't know about them, he remains very quiet. Okay? And this guy and I used to work together about 27 years ago for a company making printed circuit boards. And he is a guy from the pre-engineering. He can foresee things in the process and addresses the pre-engineering to have a stable, reliable, repeatable, consistent process. So that's where Sakti comes from, with 30 years of professional experience. Shakti specializes in providing advanced front-end solutions in PCB CAD/CAM manufacturing and assembly process. His expertise includes PCB manufacturing and EMS, DFM aimed at improving production yield and overall process efficiency. That's where he comes from. He is proficient in design and supply of PCB assembly jigs and fixtures, supporting optimized assembly operations. He has also conducted technical workshops on SMT stencil manufacturing for SMTA and various EMS companies, contributing significantly to industry capability building and knowledge sharing. So let's give one round of applause for Shakti. And I'm going to talk about another very important person, another unsung hero, always quiet, but I know the depth he has in the process. Can you believe, normally in any assembly process, right, we talk about yield and quality, and we talk about PPM, right? Can somebody here who is in the industry quickly tell me what is the normal PPM of your process yield? Can somebody tell me? Normally, how much will be the PPM in assembly process? 400, 500, right? Can you believe this company where he runs Nokia networks operates at 1 ppm. So that's why we brought Param here to talk about the process, the things he optimized in his process to discuss about. So he's an engineering professional, he's Mr. Parameshwaran, head product transfer and digital manufacturing, Nokia Solutions and Networks India Private Limited. An engineering professional having experience spanning over 30 years in the electronics manufacturing industry, currently leading the product transfer and digital manufacturing function at Nokia's Chennai factory, has hands-on experience in manufacturing, field engineering, reverse logistics, and production engineering roles in various multinational companies with considerable international exposure. Very passionate about adoption of new technologies in furthering Industry 5.0 implementation to improve manufacturing operations. He will talk about reliability. He will talk about his devices which are kept in the cell phone towers, rain or shine, okay? How they stay performing all throughout in the lifespan. So he will talk about what he did, something very important in his process, which is enabling those devices to work continuously, non-stop, okay? And we are coming to another big unsung hero of our industry, whom I have seen, I probably, 30 plus years ago, working for, right from those days. Electronics was the only company in the very beginning in the country who had SMT lines, who brought technologies, who brought, can you believe in 1990s, they made hard disk in India. Hard disk was made in India, and from those, companies, Mr. Jagdish Rajagopalan, ESDM, now planted of Larsen & Toubro, and they are going to do industrial electronics, power electronics. One of the veteran in the industry who understands operations, who knows a lot about equipment, who is a lot invested into now current technologies of AI and data. He will talk about how AI and data is enabling the process for the products they make more reliable and with a zero defect. So I'll talk about Jagdish, a senior leader. He drives convergence of electronics manufacturing, smart factories, and digital transformation to build scalable, globally competitive, and future-ready operations. His expertise spans in electronics manufacturing services, smart factories, covering SMT system integration, high reliability manufacturing industry 4.0, 5.0 adoption, and world-class quality systems across consumer electronics, automotive, industrial, data center infrastructure, power electronics, semiconductor, OSAT system level, defense and aerospace. So he works across segments with the immense experience in operations, and he used to be the head of engineering also in the previous tenure, so who understands process much better. So he has set up greenfield and scale-up operations from factory concept, capex planning and equipment strategy to rapid ramp-up, yield stabilization and operational excellence. So he has got about more than 2 decades of global leadership. He has had senior leadership roles at Dixon, Wistron Flex. His current focus is on building digitally enabled, resilient manufacturing ecosystems where electronics, cloud, AI, and intelligent automation come together to deliver speed, quality, and cost leadership. So we will ask him more questions about machine-to-machine communications, data is using to enable the processes. So without wasting much of time, I'll go and ask them relevant questions today. Yeah, let me begin with Shaktivel, who is with the MST technologies into pre-engineering. So Shakti, if you have the mic with you, okay. Today's topic is on the reliability edge and enabling to have a zero defect in the assembly process. As you are one of the a pioneer in pre-engineering, I would like to ask you, when you receive a Gerber file from your customer, what would run into your mind? How will you enable your customer with your inputs into the stencil manufacturing, for example, to ensure that they have whatever they required to achieve the zero defect and reliability in the assembly, things you do. Can you please develop on that?
Good afternoon, Richard. When I say the zero defect, studying the Gerber data, customer, first you understand customer application. So what product is going to drive? Understand the complications and go through the impact which going to create, the product which is going to create. So conduct a proper DFM, that design for manufacturability. That is the key point. Before that, you should understand the product knowledge base. You should really understand. Then only you can give a proper suggestions, engineering driving to the customers. Without having the data or product knowledge, it is very hard, or you assume in the air.
Enable them to have a very good stencil. What are the things you are looking for from the customer?
Again, it's all product driven. They should understand the common spacings, mainly the common spacing, wherein that is the one playing a part in assembly defects. So you need to, in order to address that issues, the Gerber data need to be detailedly study on the common spacing mainly, the package reliability, and the board, the basic circuit board, the surface finishes, the board materials. That is the one need to be really considered.
Okay, I know that you look at your PCB and look at the fine pitch as well as the pads where your transfer efficiency has to be improved.
Yeah.
So did you ever address that, nowadays by default, or you still talk to customer that you can?
No, that's all again depends on the package footprints. That when you go for a PCB assembly, the stencil plays a first tool. That is a critical tool which need to be really given a more concentration, more priority to that. So the data manipulation, data steadiness, and the surface treatment all need to be considered. And the normal consumer electronics, where the LED boards for the low cost product, you don't need to pay more attention. But when it goes for the branded one and the high quality one, then we need to talk to customer what kind of a DFM need to be done and what kind of a materials to be considered. And process treatments. This need to be addressed there.
Okay, got your point. Param, yes, you are very deep into the process in your company. And over a period of time, you have even taken multiple roles within the organization, right from the process engineering. You have achieved, which is, I mean, more than international level. I would say that, 1 ppm is not a joke. And with the kind of materials we see you have in your assembly, the thick PCBs, 3.2 mm thickness PCBs, where you have the challenge to have hole fills. With all that, can you tell me things which your team and you have done in your company to enable this 1 ppm in your process? Can you dwell upon things which you optimized in the process, right from the pre-engineering, from the printing to the placement to the reflow? Can you please dwell upon that and share your experience to the team?
Yeah. Thank you. Thanks for the question, Richard. So before that, a quick introduction of Nokia, right? So I think still everyone will be thinking that we are making mobile phones. So disclaimer here, we don't make phones anymore, and we make the network equipment that we supply to communication service providers like Airtel, Jio, and Vodafone Idea. And they establish a network and they provide the service to you. So that's how we are now currently operating. So, and Richard also mentioned that our equipment is put directly onto the tower. Earlier it used to be during the 2G and 3G days, it used to be in a room, like we used to call a base station, and it used to be in a controlled environment. But now the concept is that the antenna and radio, everything is combined together and put directly on the tower, and it is facing all kinds of the environment, right, harsh environment. So when we were manufacturing that, we understood that the focus should be on the reliability, and for that, as you all know, that SMT, where we start building the boards, right? So that is the main, it's a, you can even say the heart of that unit, right? So that's how we decided as a team to focus on improving the quality there, because that finally builds the quality of the product. And we brainstormed to see how we can break this, the ppm, how we can bring this ppm to such a low level, right? So when we say what was the approach, if you see, basically, how to work on the different, the 4 M's, right? The traditional way of working, the 4 M's, man, material, and man, material, machine, and the methods, right? So we started working, and for each, starting from the process, right, from the starting, print. So we started printing, then placement. So we started addressing each area, these 4 variables, right? How to study the variable, what are the variables there first, and then how do we bring in solutions or process optimization to address those variations. So it's a very vast topic, so I will just touch upon the main key actions, and maybe as we go we can dwell upon the other topics also. So coming to the placement, so as we all know, right, most of the, like 70%, around 70% of the defects can originate from there. That's the statistics we have as an industry. So here what we did was, one was how to use effective use of the SPI. So solder paste inspection. So we do the printing, and then it is inspected using the solder paste inspection. So there we brought in automation, really the camera based inspection, and effectively how to use it. So one thing is like we use the closed loop feedback. So that is when the SPI detects there is a shift, continuous 3 boards, there is a shift in offset, then we enabled it to talk to the printer to autocorrect. So that is one of the example. Then on the material side, if you see, we see that there is always variations with the PCB, right? Batch to batch, and supply to supplier. There is always, this is like the real world problems, right? Yes. There is always a variation from batch to batch. So how to address that? So there we again talk to our partners like Shaktivel and other suppliers, like how do we address those variations, and we had this idea of reverse engineering the stencil. So you were asking about how. So reverse engineer the stencil based on the actual PCB that we get and not with the Gerber, because we see that there is a variation here. It's not as per the Gerber.
Not as per the Gerber, yes.
How do we do that? So
yes.
we did that, and so whenever we have a variation, we change over to this stencil. So this is key, one of the things that was few things that we did on the printing side. Apart from management of the solder paste, the thawing, and how do we have a pokayoke there? Like we know that we need to use the stencil, the paste after the 4 hours of thawing.
Okay.
So how do we ensure that that is done repeatably? So there we did some kind of solutions, like the operator, like a single piece flow, the operator can only take out the paste after the 4 hours is done.
Okay.
So these are some of the things that we did on the printer side. And also there is, and then on the placement side, where as you all know, the SMT placement accuracy improves. The main topic is on the maintenance. So how well it is, head is maintained, nozzle is maintained, and feeders are maintained and calibrated. So there to bring in the repeatability, and we automated that process. So we used like automatic machines to do the maintenance. So we have always we remove the variability of the engineer or skill of the engineer, because we found that sometimes if the skilled engineer is not there, the maintenance is not done properly. So there we had this kind of automating the process to have to remove the variations there. And then also the pre-reflow AOI, getting the feedback to the placement machine and those kind of things. And the reflow side, we have this continuous monitoring of the profile. So initially it used to be just set up during the NPI, and then we monitor it maybe once in a month and things like that. But then we moved from that to a 24/7 monitoring of the profile using that is all available. The technology is available. So we adopted it to so that is helping us to have a reflow under control kind of things. So these are the few things. Maybe we can discuss the remaining as we go on.
As we deep dive.
So with this, we were able to bring down the soldering ppm to this level and maintain it for many years.
Many years. So that's
good.
That's very. I mean, that's called consistency. Yeah. Okay. So Jagdish ji, we visited one of industrial manufacturing companies in the western side of India, precisely in Udaipur. So Rajeshwar and I went into the factory. So they made a process without any manual intervention. They only stack boards. The entire line is self-operative, and the output is only in the trays. The operator picks up the boards for the next operation. So that's the kind. In fact, in that operation is only for box build. So we were amazed at it. But as you are very well experienced in operations, you have seen multiple companies wherever you served, and doing in multiple segments. Do you think that today is really possible, the kind of quality which can be attributed to the assemblies we do through the equipment, especially, like Param said, machine-to-machine communication, using artificial intelligence and data, which you are now currently working on, and you have that expertise. Can you please share it with the audience, with your experience on that?
Yeah. Thank you, Richard. And first of all, I would like to take this opportunity to thank Elsina to share my knowledge to the audience. See, as Richard said, actually, we are not into all in multinational companies. I am into a tier 2, tier 3. So even if you see what Param and Sakti, they mentioned about the machine-to-machine and the DFO, those things at tier 2, tier 3 cannot offer. But the data, AI is nothing but the data. It's a manipulation of all data. So if you see the data, if we are able to find from your machine, especially for SPI, if you are able to continuously monitor the data, that even with the Excel, we can see the drift in our process and we can stabilize. Similar, so now the Richard asked about this dark room concept, that is end-to-end without any intervention. There is no handling of PCBs by the operator. It goes end-to-end. I have seen multiple companies in China, they are doing the dark room concept. But for coming to India, this is actually the ROI is return of investment is almost 4 times than the China. So it's as of now it's not viable for ROI perspective, but it is already proven in India also. We have done it in one such plant to do manless operation. My suggestion is with the data available, with the AI engine like Llama or generative AI, we can do with the minimum manpower, with the predictive analysis and all the things, we can run the plant with the maximum efficiency as well as the PPM. But really I'm surprised when Param is saying 1 ppm, because even it's really a wonderful job you have done. So the thing is that whatever the knowledge the expertise is having, we can input to the AI data. AI nothing which is the collection of data and it will do the prediction. So I am working on that, where I will take the experts from the industry, I will put it on the SPI, AOI and make that visible to the people to make the judgment. So even the machine by itself we can take the judgment, but for the tier 2, tier 3, it will give the audience or the engineers to take a decision to correct the problem by itself. By that time, we may not require Saktivel and Param in all the companies.
Okay.
They are the experts, correct? So we need to take the inputs from them and we can have a data set. The data set can be a generative and give a decision to the engineers for tier 2, tier 3 to take a decision.
Okay.
Correct? What Param said is actually it's exactly the requirement in all industries. So the SPI is the key. When you see the data from SPI and the 3 consecutive failure or the data get drifts, your AI data can predict. Only you need to collect the data and put it into a generative AI. And the AI can predict that your data is drifting. And it can say your stencil gone worn out. You can ask Saktivel to design a new stencil. Or if the cleaning is not good, then you can instruct your engineers to clean the stencil. So it's all about the SPI data to take care of the printing quality. And coming to this complete line machine-to-machine communication, SPI and printer having interconnect, as Param said, it will correct automatically by itself. But it's also needs some time to mature. Now currently, if there is any offset, this printer will correct the X offset and Y offset automatically, but that's not be a permanent solution. So the next board, when it goes, maybe a fiducial problem, it get offset, the similar problem may come in the next board also. So it's need to have some fine tuning further. And more important, there are some other parameters that current machine, SPI machine or even the printer, they are not connected. There's a forum, as Param rightly mentioned about the forum environment that influence the printing defects, correct? Now, the SPI only correlates with the printing machine. So it will adjust the pressure parameter and this. But after period of some time, there is other parameter, because viscosity is an important parameter, it runs with the time. So that is also going to play a critical role. So those things actually we need to add into the AI system, and to get mature it may take some time. What I believe is we can collect the data, put our AI on a machine and predict whether it's belong to our environment or it's going to be a machine oriented, then can take a decision. But coming to your point, that end-to-end automation, it is quite remarkable. I have seen in you have seen here, but I have seen in China, it's a dark room. They switch off the light and they are running the SMT line. Even the feeder loading itself, it's automatic.
Oh, okay.
So these things can happen in India when our operational cost is more than the machine cost. So that's quite challenging now.
Okay. Okay. Param, I'm going to ask you, okay, please.
So that you were talking about the viscosities, right? So that is one point that I missed. So for that, what we did is, again, we had put a IoT solution inside the printer, where it will continuously measure the temperature and humidity inside the printer. And that whenever this is getting, within, we monitor that it is within the spec, and if it is going out, it gives a, alert to the technician to take the corrective action. So that is one more action that we have taken for that.
Okay.
And to coming to the AI part, so I still believe that even after the implementation of AI, I still believe that there will be a human in the loop to check if the AI has given the right decision, so that our job is also safeguarded.
Okay.
No, actually the data correlation need to be done by the experts only. So
Yes. Param, I would like to further deep dive into materials which are, varying from suppliers. The variability comes, say for example, PCB. When you get, say, multiple supply sources and batch to batch variation within each supplier, and you have multiple suppliers, and you have solder mask misalignments also be there. Likewise, you have more variabilities attributing from the material side to your process. So we know that, yes, you use AI and data to optimize your process, right? How do you capture these variabilities into your, you have incoming quality guys who are able to understand and give you the data that this batch has to be done. Like Shakti used to do a kind of DFM. So you have such a process in place within your company that, these variabilities, how do you manage? Components, PCBs, including the soldering materials, all this.
So actually, if you see nowadays, right, the incoming quality inspection, it is actually considered as a non-value add.
Yes.
So it is again, we need to work with our partners, that is suppliers, and to see how they can give the consistent quality over a period of time. So that's the way we operate. Because if you see, like, we are at any point of time handling around 4,500 line items, part numbers, if I see, for all the variants that we make. So inspecting each and every line item with all this criteria is not it's a feasible thing, right? So what we usually do is, like, if there are historical cases, then those will be flagged and those will be inspected, where we have a quality engineering lab with all the required equipment, like for example the VMS, and then we also have capability to do the cross sections to see if there is any process issues, to see the cross sections, so we can make cross sections. Then other equipments are there to do the measurements and do the analysis for the parts which we know that in the past there is a issue. So for those are addressed through this, but otherwise it is all the in-process control that we have. Like I said, we have the SPI here, then we have after placement we have a AOI, then after reflow we have an AOI, and then we have this continuous monitoring. So we have done the digitalization to have the continuous data collected from all these machines to see how it is trending. So there is every shift every hour we know that what is happening, what is changing. So those kind of
initiatives which will help in quickly reacting to any changes that
Okay.
is happening.
Okay.
So that's the way. So incoming quality inspection, we say it's like around 10% is what we usually do.
Okay.
But then if it is known cases, then we address it, case by case we address it separately.
Sure. Shakti, turning to you. You are working with one of the most expensive mobile manufacturer, okay? And they have identified you after auditing you, your capabilities. And now you are one of their very reliable supplier. For improving the process, yield, and also on reliability, because nowadays you can see the kind of fine pitch PCB design in latest model of mobile PCBA is, is really fine pitch. The component choices are also shrink down. Now the real estate is shrinking, ever shrinking. So there they have the challenge of transfer efficiency, right? So I know that you also have introduced a new process in your stencil technologies. Can you please explain to the technical people here who are here or the other assemblers here, what kind of new materials, especially the stencil materials, which you are buying from Japan, have changed over a period of time? And also the kind of surface coatings today you are using, which are enabling your customers to have a better transfer efficiency of paste to the board. So can you please elaborate on that?
Very recent days, we see the component pitch, which is less than a 0.3 mm, and the opening of apertures, that is footprint of the component, each leg pin width size is 0.13 mm, which is closer to 5 mil pad size. So customer has a tough time, or we conducted a DFM, then we arrived at material which is called a SUS 301, which is called fine grain stainless steel foil, where the grain size of the foil is only less than a micron when compared to conventional foil, which is SUS 304, wherein there it has a 25 micron grain size. But recent, for all the high fine pitch component, we are using fine grain foils, and that has been treated after laser cut. We fabricate a stencil using laser machines, where the laser energy is making punching the holes with the high pulsed laser, creating a burr. So where we do the deburring, polishing method, and that also could not able to solve the transfer efficiency. There is a problem. And recent days, customer, even though we reduce the foil thickness, which is 60 micron or 80 micron, customers still have the transfer efficiency because of the component footprint. So we have to adjust the surface treatment, wherein to bring the area ratio and upper area ratio, which is 0.66, aspect ratio of 1.5, we change into 0.6 into 0.55 with help of nano coating, which is called permanent nano coating. When we say we address it's a advanced nano coating with CVD method, chemical vapor deposition, wherein the coating thickness, nano coating thickness, which has been obtained by silicon dioxide with the diffusion method been done in the vacuum chamber, and the coating thickness is 100 to 200 nanometers. That was the one really helping the customer, achieving the area ratio, which is less than 0.5 mm. 0.5.
Less than 0.5.
Yeah, that is a consistency, and that coating is indirectly helping the productivity, which is under wiping cleaning during the printing process. And instead of a 10 board, they make a 5 board. Sorry, instead of 5 board, they're making the 10 boards. And the direct consumable savings also, and improving the productivity.
That's important, yeah.
and gives 100% confidence with the customer, wherein their involvement on inspection has been reduced. Direct online has been done now.
Yeah.
So that is where we could able to concentrate. Concentrate on developing the method, stencil bits method, and we have a team which carries. They have been carrying almost 20 years of experience since last.
Okay.
Years. Almost 3 people are there, and we have been guided by customers, and we handle more than closer to 20,000 different varieties of data. Adding that experience, we put all this experience in the tool. Stencil is the one which is the first tool which is directly reflecting over defect ratio, yield ratio. So we really concentrate on that side.
Okay. Thank you, thank you. Param, before I come to you, I'll go to Mr. Jagdish. Jagdish, many tier 2 and tier 3 manufacturers see the AI-driven correcting SMT lines like Param's company can afford. They have capex budgets are bigger. But what do you suggest? I mean, as an industry veteran, it could be out of reach for, say, a newcomer into the industry who is going to invest in maybe 2 lines, 3 lines. Okay, can a smaller player achieve that reliability edge without replacing their entire shop floor with the latest equipment or robots which you can think about? Can you just dwell upon that?
Yeah, it's a nice question, sir. The thing is, hello?
Yeah, you can take this.
It's an interesting question. Most actually I worked around 20 years back in the similar platform where we don't have this kind of data and machine-to-machine communication. So when I see that time actually human intervention is more to take the decision, correct? Now, when I think back the same machine, that also generating the data, but we are not using the data. Now, what the current AI, the same system, we can have a separate machine. With the older generation machine, we can pull up the data and put it in a large model AI solution. There is a Llama solution available. It's an open source. We can pull the data and the decision can be given by the Llama project by itself to the engineers. So still it's affordable and it can be trained by their own engineers.
Okay.
We can have, it's an open source. So we need to collect the data, but it's not going to work out for a high mix, low volume. It's going to work out for high volume, low mix, because it has to give more data to take a decision. And it will show the trend, how it behaves. Even in the current AI scenario also, the data, how much data, then the prediction will be good. If it is a lesser data, the prediction may not be good even with the current machine data also. So what I suggest is they can pull out the data from the SPI, from the AOI. SPI data can give the drift from the solder paste printing machine, and AOI data can give clear vision of which nozzle, which head having the problem, which machine is giving the problem. That even with the old generation machine, we have the data, only we need to put this current AI generation, that Llama is a generative AI, it's open source, we can pull the data and put it into the Llama generative code, then it will automatically give the feedback, but only the decision need to be taken by the human. But the solution is available for the even tier 2, tier 3 industrial people also.
Okay. Thank you so much. Param, I'm going to ask you this simple question now. With your experience over a period of time, in your process, we have come across so much of defects, we have done root cause analysis, and we have figured out where the cause comes from, and we developed solutions. Today, how do you say confidently that, hey, these defects are no more in the assembly process? Okay, and that's question number 1, that which you have overcome permanently in your process, no more existing in your line or process. Question number 2 is, what is the current challenge you have in process to achieve the reliability edge or zero defect in your process?
Okay, good question. So if you see over the period of time, what we learned and with all this solutions that we were discussing, right? So we can say that defects like bridging and those kind of defects, which can be easily caught at the SPA itself. So those are like almost we can say is eliminated.
Disappeared.
So, yeah,
okay.
So almost because it is we have AOA after the final end of line AOA, then we have SPA. So these are the ones which we can confidently say can be easily eliminated from our process when we have this kind of solutions. And then to an extent, we can also say about the offset because we have this closed loop, like
communication, machine-to-machine communication.
And there is also a feed forward. That is, SPA can also give a command to the placement machine.
Okay.
So when there is an offset found in the PCB as a printing, and if it is within the acceptable limit, if it within our acceptable limit as per the IPC standard, we can also, the SPA can tell the printer to place it offset so that it is sitting right on the paste.
Okay.
And in the reflow anyway, it will get realigned.
Okay.
So with this, this offset kind of, this is also reduced to some extent, you can say. And then coming to the second question on what is the current challenge from the reliability point of view is two things I would say. One is on the voiding. So voiding when it comes to the bottom terminated
BTC components.
BTCs.
Yeah.
And then we also have this power amplifiers where we have this MOSFET, and so these are some of the challenges on the voiding side, where we are continuously working how to optimize the process. That is on the process side, optimize the process with the reflow, work on the reflow, then printing, then also on the material side, use of the right kind of preforms and things like that, right? So that is the current challenge that is still there, and then we are continuously seeing how to improve that. And second will be on the thermal interface materials, where when you power on the electronics, then the big ICs, microprocessors generate a lot of heat, right? So that has to be taken out, pulled out from the PCB and then sent to the environment, right? So that the electronics functions properly. So this is another challenge on the thermal interface. So there we are having solutions on like AI enabled solutions on inspection. So after the machine dispenses the thermal gel, before assembling, we are ensuring with this kind of solution that the right amount is there or not.
Okay.
So, and for the voiding, one more thing is that bringing the effective use of AXI. So that is coming as a now. Earlier it used to be on a sampling basis. Now we are seeing a lot and more use of AXI into the process apart from the AOI.
Okay.
So this are the, I think I would say, the current challenges which we are still working on.
Okay. As a follow-up, if you don't mind, I'll ask one question which, if you're comfortable. How do you, see your company has got multiple factories across the world. Where do you place India factory in terms of reliability, zero defects, yield, everything? Where do you?
Yeah, so if you see Nokia own factories, we have, this is our biggest factory.
Biggest in India, okay.
Chennai.
Right.
No, even globally if you see, Nokia own.
Okay.
We have one in Finland which is more into the NPI.
NPI, yeah.
And the volume wise, we are the biggest factory, and we have been operating for now more than 17 years from Chennai, supplying to both India and the world markets. Okay, so and other regions we operate through partners.
Partners,
so we have EMS supply partners who we are working with. So from the quality standpoint, I would proudly say that we are
number one.
We could consider as the number one.
Number one, okay.
Globally also.
Great,
so,
great.
Yeah. So when the R&D, they're coming with the new products, we see that for the NPIs and first volume ramp-ups, they prefer to work with us, the different R&Ds who are in the other, like R&Ds are in Finland and US and China.
Super.
So
Yeah.
that is a proud moment, I would say.
Thank you for answering that. Okay, so we still have about 7 minutes left. I'll keep 5 minutes for a Q&A. Before we wind up, one last question I would like to talk to Jagdish ji. Jagdish ji, you have done so much of systems, processes developed within the organization, and you have trained people, skilled people. So if there are people leaving suddenly, do you experience again there is a challenge to the throughput, yield, or quality with the people moving around? If there's an attrition, is it affecting your assembly process?
It's actually,
and how do you counter that?
Yeah. So this is a very difficult challenge in the industry right now. So the electronic industry growing up, and we have this challenge. So 6 months back, we have taken an initiative. Actually, using this AI model, we actually input all the problem statements and the solution. And we have trained our GETs. We hired some GETs for that. And we collect all the data from the training, from the expertise to the people, how to coach the newcomers to adapt to the situation and deliver immediately. So they have that AI assistant with them. We are giving an AI assistant with them for any decision making or anything on the line issues. They can just check with the AI assistant to get the solution. And sometimes 90% actually it gives the correct result, and 10% again it need an expert to come in and give the solution. So this way we are handling as of now with the AI tutor. We can call AI tutor.
Okay.
We can give all the information. You can check like a chat GPT, you can check about our industry requirement. If there is a solder short, what I need to do. It will give a hierarchical way. First clean the stencil and check whether the stencil is getting clogged or not. So those are the things we give for the new people to quickly adapt to the situation. But the challenge is there actually when the new people suddenly comes to the line, they may take some time to adjust, that the AI assistant will help them to quickly grab the situation.
Okay. Thank you. So before I wind up, there is a summary for whatever we discussed. Like yesterday's session, Josh was telling, when he made a Nokia phone in India, they were not able to attract buyers from overseas. They had a doubt on, India-made Nokia. Then he brought all of them to the lines in Chennai, and when they saw it from Southeast Asia, Africa, Middle East, and they were really overwhelmed with the kind of quality that is going into the product. And I believe that after that, there was no looking back. Everybody bought and they understood the India quality. I'm having an access to visit most of the companies in India who are in multiple segments. I can confidently say that we are probably on par or better than the people whom we see in the neighboring countries, at least where we visit other countries too, where we say that we are no less than anybody. So we have very qualified engineers, and we have understood where the root causes of defects could come from, and we are proactively preventing those defects in the lines. And now there is a standing example of company called Nokia Networks, where their PPM is just 1 PPM today for the yields when they are seeing in their processes. So this it has got direct impact on the company's top line growth, higher customer trust, more business, ability to enter high reliability segments, reduce time to market for new products, low field failures, and for the bottom line, low cost of poor quality. Okay, fewer line stops and downtime, reduced warranty and RMI costs, and predictable quality enables leaner inventory also, and automation and process control is labor efficiency. And for strategic business impact, reliability as a competitive moat, data-driven manufacturing enables scalable, repeatable growth. So with that, and like Ilan said, we are going to be most sought after country for electronics in about 5 years' time, and we will be giving a lot to the world. So with this, I can take some questions if you have. We have 2 minutes left. Yeah. You want the mic? Yeah. Maybe 2 questions, please. Yeah.
Good afternoon. My name is Tyagarajan. I'm from New Line Technology, past president of Indian Printed Circuit Association. Very commendable to see that 1 ppm and the data that you're using to manufacture very high quality product. The thing is that how much these following standards, like we have design standards in terms of mill standards, IPC standards,
yes.
JA standards in India,
yes.
matter in terms of reliability of the system. For example, we brought in all of the designers to be certified to follow the design procedures. Okay, this is a question. How much you follow the design standard will have an implication on the product.
Param, you want to take that? Yeah.
Yeah. So if you see in our setup, right, so we follow this IPC as a main guideline. And we also make sure that the cross-functional teams, so like from the quality and production and engineering. So we almost, if I see the count, if you see like around 18 people, they are IPC certified by an external agency. So that they will then impart the same training to all the operators also. So all our operators who are in the who are at the manning the AOIs, where they do the judgment, right, whether this is acceptable or not. So everybody is trained on the IPC standard. So that is a basic training criteria for all the critical resources that we deploy across the shop floor.
Yeah. Next question, please. Yeah.
So good afternoon. My question is to Mr. Jagdish Rajgopalan. Sir, hello. So you said that you are using something like Llama AI API, something for that. My question is, if it is a large language model, it is actually probabilistic in nature, because these models are built on neural networks where each nodes actually get a small thing which computes and gets, and it is based on weights, Bayesian networks, probability. When it comes to science cannot be probabilistic, right? It should be deterministic, to be honest. Because, as you said, the theme is actually based on zero defect. How can like AI being used in this, how will this progress? Because for a dark room, I think if there is no human needed in that room, we need something which is like picture perfect, which cannot have something like this. Are we training models based on data which is like developed through these SPI? Like, why we should not develop our own AI, like a sovereign AI, like which IIT recently launched, something like that, rather than focusing on an architecture which is already done by someone in some other countries or something like that? Thank you.
It's a very nice question. See, we are not actually developing an AI here. We are going to use our SPA AOI data to give a solution. This is the open source platform. This is the next topic, that what you are saying, we can develop AI tool for our own. That we can do it, but what I am saying, AI, it's not only SPA data and follow up with the defect. So it will be a cycle. If this is the volume, and what would be the defect, that closed loop has to fit into the system. Then only the SPA, that large model, can give you the result, correct? It's not only open end, we can give only the SPA data, it will not be able to tell whether this will going to have a problem or not. So it's a closed loop. When in the Llama solution, we need to give a complete data, where what is the volume and what is the end result in the testing, it's fail or pass. This complete closed loop data need to be fed into the AI, then only it will give the decision making. Okay, and the second part you are saying, why we are using Llama, why can't we use our own AI? That actually we need to develop, okay? That's, I am not into AI. I am actually going to see the solution where I can get it from AI, okay? I answered your question.
I hope that solves, yeah, okay.
Last question. So this is to Param Shoranji. So when you started the 0 ppm project, and definitely you have done some data analysis in the first phase. So what was the top hitter, top defects you identified, the first 3 top defects, and what is the quick fix for that? Because there are still some manufacturer, I also not fortunate enough to achieve that 1 ppm. So what are the top hitters? What were the top?
Yeah, so top hitters were like, one was that I was mentioning earlier, so bridging was one of the top hitters. Then we have because of the offsets that we are seeing, we were having this tombstoning. Tombstoning was more. And the design also, we started, though our board is big, but still we started using the smaller components. You won't believe that we also have O2 oven in our board, though with a big real estate we can afford to have bigger components. But so these were the top, I would say, the bridging, and then tombstoning, and then maybe third, maybe the insufficient solder. So that's where we use this, whatever we were discussing on the closed loop, and then the effective use of SPI, and then the other process controls on the input side.
And this is out of curiosity, how much time it took you to achieve this 1 ppm when you started and now? Okay.
It was like maybe we took around 4 to 5 months, I think, for the first. So how we approached is, we first took one line. So we took one line and we did all this, whatever, we implemented all that solutions, and we achieved that in maybe 5 to 6, maybe 5 months. Then we saw the sustenance, and then we did the horizontal deployment to all the lines.
So we can still talk over the lunch. I mean, we have time. Okay. Okay. So thank you, Jagdish. Thank you, Param. Thank you, Shaktivel. And we thank Elsina for accepting this subject into the discussion. So we close this session now. Thank you very much for,
Thank you once again for our moderator for handling the session seamlessly, and give a huge round of applause for all our panelists for sharing their valuable inputs. May I now request Mr. P. Karthikeyan, Head Distribution Hub India, to please join us on the stage to present the memento. Mr. P. Karthikeyan from Nokia, can we give a huge round of applause, everybody together? Let's give a huge round of applause for Mr. Richard Putota, Senior VP, Elsina, and Senior Director, McDermott Alpha. Ladies and gentlemen, let's give a huge round of applause for Mr. Saktivel Padmanabhan, General Manager, MST Manufacturing Technologies. On the panelists, we also had Mr. Parmeswaran S., Head Product Transfer and Digital Manufacturing, Nokia Solutions and Networks India Private Limited. Mr. Jagdish Rajagopalan, ESDM Plant Head, Larsen and Tobro. Can we give a huge round of applause, everybody together once again? And we would like to thank Mr. P. Karthikeyan from Nokia, Head Distribution Hub India, for presenting the memento for all our panelists and for our moderator.